आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone. Question says that a line L1 with direction ratios -3 to 4 passes through the point A762 and a line L2 with direction ratios 213 passes through the point B534. A line L3 with direction ratios 2 -2 -1 intersects L1 and L2 at the point C and D. Then we have to find the length of CD. That is, we have to find the length of the line segment that is joining the intersection point of L3 and L1 with L3 and L2. So we have given three lines. So let us talk about L1 line first. So about L1 we have given that its direction ratios are -3 to 4. Direction ratios are denoted by A, B, C. Let's say A1 we have is -3, B1 is 2 and C1 is 4. And these are the direction ratios of line L1. Also we have a point A762 through which the line L1 is passing through. So we have a point x1, y1, z1. x1 we have is 7, y1 is 6 and z1 is 2. These are the point. This denote the point at L1. Now we know equation of a line in Cartesian form is given as x minus x1 divided by its direction ratio is equals to y minus y1 divided by b1 and z minus z1 divided by c1 with which is equals to some constant, let's say lambda 1. This is the equation of a line passing through a given point and is parallel to a given vector whose direction ratios are the direction ratios of the line. So this is the equation. We have to put x1 here. So this is x1 we have 7, a1 is -3, y minus y1 we have 6, b1 is 2, z minus z1 that is z minus 2 divided by c1 we have is 4 which is equals to lambda 1, and from here if we equate each term with the constant lambda 1 then we will get x is equals to -3 lambda 1 plus 7, y will be 2 lambda 1 plus 6 and z will be 4 lambda 1 plus 2. So by equating each term with lambda 1 we have get x, y, z random points on the L1 line. So here x, y, z, these points are points on L1. Now consider the line L2 that we have given. So L2 line has direction ratios 213 and it is passing through 534. So for L2 we have A2, B2 and C2. Similarly, we have A2, B2, C2, that is the direction ratios 213. This is 2, this is 1 and this is 3. And the point through which the line L2 is passing is 534. So this is x2, y2, z2. We are denoting the point through which line L2 is passing as x2, y2, z2. So these are the points 5, 3 and 4. Now similarly, by using the Cartesian form of line, the Cartesian equation of line, x minus x1, we have x minus x2 divided by a2, y minus y2 divided by b2, z minus z2 divided by c2. So this will give x minus x2 we have is 5 by 2, a2 is 2 is equals to y minus 3 by 1 is equals to z minus z2 that is 4 divided by 3c2. And we know this is equals to some constant, let's say lambda 2. So from here, if we equate each term with lambda 2, this will give x is equals to 2 lambda 2 plus 5. Y will be lambda 2 plus 3. And z will be 3 lambda 2 plus 4. So these are the points on these x, y, z are the points on L2 line. So we have obtained the points on L1 line as well as on L2 line. Now consider the line L3 that we. So this line L3 has direction ratios 2, -2, -1, and it is saying that this line intersects L1 as well as L2. So let's say this line, we are first considering that this line L3 is intersecting L1. So that means if there is a line L1, this is some line L1, and there is some line L2, then L3 is the line that is passing through both the lines. So this is the line L1, this is L2, and this is the line L3. So we have find out the points x, y, z on L1. On L1, the points x, y, z are taking the form this. So when we put lambda 1 here, we will be able to get x, y, z, that is the points on the line L1. And similarly for L2, when we put lambda 2 here, we will be able to find the points on L2 line. Now L3 is passing through L1 and L2. So there must be an intersection point. Let's say this is the intersection point. And let's say they have said that we have denoted these points as C and D. So let's say this is the point C and this is the point D, whose coordinates we need to find out. So let's say we denote these coordinates with, let's say x3, y3, z3. And the coordinates of D we are denoting with x4, y4 and z4. Now this coordinate of C is a common point of L1 line and L3 line, and this coordinate D is a common point of L2 line and L3 line. So moving forward, we are using this thing that C is the common point of L1 and L3. That means C coordinate will satisfy the equation of line L1 as well as the equation of line L3. So the equation of line L1, from L1 we have got that x, y, z follows this rule, and we have to find out the value of lambda 1 here. Let us find out the equation of line L3. So equation of line L3 on the similar basis, since we have given direction ratios of line L3, they are 2, -2, -1. So let's say we are denoting them with A3, B3 and C3. So it is 2, this is -2, and C we have is -1. 2, -2, -1. So from here, equation of line L3 in the Cartesian form will be x minus, let's say there is some point x3. So x3, y3, z3 is one of the point of L3. So we can write it here x3, because in the Cartesian form, Cartesian equation of line, we put here the points x1, y1, z1 denotes the points through which the line is passing through. So x3, y3, z3 is also a point through which L3 is passing. So we can write down x3 here and the direction ratio here, A3. Y minus y3 over, this is b3, c3. And z minus z3 over c3 is equals to some other constant lambda 3. And from here, x minus x3 as it is, we have to find out x3, and we have 2 here This is y minus y3 over minus 2, and this is z minus z3 over minus 1 is equals to lambda 3. Now equating each term with lambda 3, this will give x is equals to 2 lambda 3 plus x3. Y will be, this is minus 2 lambda 3 plus y3, and z will be minus lambda 3 plus z3. Now we know x3, y3, z3 is a common point of L1 and L3. That means x3, y3, z3 will also satisfy the points of L1 line. So these were the points of L1 line. So if we can put x3, y3, z3 here, and we'll be finding the value of lambda. So we have x3, y3, z3 from the equation of line L1. This will be x3, this will be y3, and this will be z3, because x3, y3, z3 satisfies all x, y, z, because x, y, z is a random point on the line L1, and x3, y3, z3 is also a point of L1. So this will satisfy the equation of x, y, z. So this is minus 3 lambda 1 plus 7. We can put it here to find out the value of x. So this is 2 lambda 3 plus x3 is minus 3 lambda 1 plus 7. This is minus 3 lambda 1 plus 7. This is minus is equals to y3. We have y3 is 2 lambda 1 plus 6. So put it here. This is minus 2 lambda 3, 2 lambda 2. This is 2 lambda 1 plus 6. And the last point that we have is 4 lambda 1 plus 2. So this will be 4 lambda 1 plus 2 minus lambda 3. So these are the coordinates of x, y, z of the line L3. So here x, y, z denotes the points on L3 line. Now similarly, since D point x4, y4, z4 is the common point of the line L2 and the line L3. So we can put x4, y4, z4 in the equation of L2. So this will be x4, y4 and z4. These points are the random points on the line L2. So we can put x4, y4, z4 also here, because they will also satisfy these points. Now we have got x4, y4, z4, and we know these points x, y, z were the points on the line L3. These were the points that we have obtained for the line L3. So x4, y4, z4 points will also satisfy the equation of the points on L3 line. So we can put here x4, y4, z4. x4, y4, this is y4, and z4 satisfies L3. So we can put them here, and x is, we have, it is equals to this value. So we will get, on putting x3 here, putting x4 here, this is 2 lambda 2 plus 5. We are substituting x3, sorry, this is x4, y4. We are substituting x4, y4, z4 here, because this satisfies line L3. So x4 we have is 2 lambda 2 plus 5, and this is equals to this value 2 lambda 3 minus 3 lambda 1 plus 7. Similarly, y4 we have lambda 2 plus 3. So this will be lambda 2 plus 3 is equals to this minus 2 lambda 3 plus 2 lambda 1 plus 6. And similarly, Z4 we have is 3 lambda 2 plus 4. So this is 3 lambda 2 plus 4 equals to this value minus lambda 3 plus 4 lambda 1 plus 2. Now we have these three system of equations in the variables lambda 1, lambda 2 and lambda 3. So let us solve them one by one. So for this equation, first equation, we can write it as this is the minus 3 lambda 1, take it to the right. So this will be 3 lambda 1 plus, and this is plus 3 lambda 1 in the left. This is plus 2 lambda 2, and take this minus 2 lambda 3 also in the left. So this is minus 2 lambda 3, and in the right, let us write all the constants. So this is 7 and this will be 7 minus 5, that will give 2. Let's say this is equation number 1. Now similarly for the second equation, this is 2 lambda 1. So this will be, let us take it here itself, 2 lambda 1, and let's take this lambda 2 here. So this will become minus lambda 2. This is minus 2 lambda 3, and let's take the constant in the other side. So this is 3 here, and 3 minus 6 will be minus 3. So this is the equation number 2. And for the last equation, 4 lambda 1, this will be minus 3 lambda 2, and this will be minus lambda 3. This is 4 minus 2, that will be 2, and this is equation number 3. So to find out lambda 1 and lambda 2, let's say first solve for 1 and 2. So for 1, we will be reducing equation 2 and equation 3 with the help of equation number 1. So let's apply 3 times equation 2 minus 2 times equation 1. So multiplying equation 2 with 3, then subtract 2 times equation number 1. So if we multiply 3 with 2, this will be 6 lambda 1 and this will be 6 lambda 1. So this will cancel out on subtraction, and multiply this with 3. This is minus 3 lambda 2. This is minus 3 times 2, 6 lambda 3. This is minus plus minus 2 times 2, 4 lambda 2, and this is minus minus plus 2 times 2, 4 lambda 3. And in the RHS we have 3 times minus 3, that will be 9, minus 2 times 2, that is 4. So this will be minus 3 lambda 2 minus 4 lambda 2 will be minus 7 lambda 2. This is minus 6 plus 4, that is minus 2 lambda 3, and this is minus 13. So we have the equation 7 lambda 2 plus 2 lambda 3 is equals to plus 13. Let's say this is equation number 4. Now similarly, we will solve equation number 1 and equation number 3 to eliminate lambda 1 variable for the fifth equation. So for that we will multiply 3 times equation 3, 3 times equation 3, and then subtract 4 times equation 1. So this is 4 times equation 1. So 3 times equation 3 will give 3 times 4, 12, and this will be 4 times 3, 12. That will cancel out, and multiplying 3 with equation 3 will give minus 9. This will be minus 3. So this is minus 9 lambda 2 and this is minus 3 lambda 3. Now this value, equation number 1 has to be multiplied with 4 and then subtract. So this is 4 times 2, 8. This will be 4 times 2, 8. So this will be minus 8 lambda 2 and this will be plus 8 lambda 3. In the RHS we have 3 times equation 3, that is 3 times 2, 6, and we have minus 4 times 2, that is 8. So this will be minus 9, minus 8, minus 17 lambda 2. This is plus 5 lambda 3 and equals to minus 2. So we have got two equations. Let's say this is equation number 5. Let us take minus common here also. So this is 17 lambda 2 minus 5 lambda 3 is equals to 2. Let's say this is equation number 5. Now we have equation 4 and equation 5 in lambda 2 and lambda 3. So by using equation 4, we will be eliminating lambda 2 in the equation number 5. For that, we have to multiply equation number 4 with 17 and then subtract 7 times equation number 5. So this will be 17 times 7, that will be 119. This will be 119 also, and this will cancel out. And then 17 times 2, that will give 34 lambda 3. And this will be minus minus plus 7 times 5, that is 35 lambda 3. In the RHS, 17 times 13, this will be 221, and minus 7 times 2, that is 14. So this is 207, and this is 69 lambda 3. So from here, lambda 3 will be 207 by 69, and this will be 69 times 1 and 2. So this is lambda 3 is 3. Now we have got lambda 3. We can find out lambda 2 from equation number 5 or equation number 4. So let's say we are putting lambda 3 in equation number 5. So this is 17 lambda 2 minus 5 times 3 is equals to 2, and 17 lambda 2 will be 5 times 3, 15 plus 2, 17, and lambda 2 will be plus 1 from here. Now put lambda 2, lambda 3 in equation number, we have equation number 1. So we have lambda 2 as 1 and lambda 3 as 3. So this will give 3 lambda 1 plus 2 lambda 2, that is 2 times 1, 2 minus lambda 3, 2 times 3, 6 is equals to 2. This is minus 4. This will be 6, and 3 lambda 1 is plus 6. So lambda 1 will be 6 divided by 3, that is 2 from here. Now we have got lambda 1 and lambda 2. So we can find out the coordinates of x3, y3, z3 and x4, y4, z4. So these are the coordinates of x4, y4, z4. On putting lambda to 1, x4 will be, this is 1, 2 plus 5, 7. This is 1 plus 3, 4. And this is 3 plus 4, 7. So coordinates of D are 7, 4, 7. Similarly, on putting lambda 1, 2. So on putting lambda 1, 2 here, x3 will be, this is minus 3 times 2, 6 plus 7 will be 1. This is 2 times 2, 4 plus 6, 10. And this is 4 times 2, 8 plus 2, 10. So the coordinates of C are 1, 10, 10. Now we have to find the length of CD. So by using distance formula, the length of CD will be, let's say we are finding it here. So this is under root of 7 minus 1 square. So 7 minus 1 will be 6 square, that is 36, plus 4 times, this is 4 minus 10, that is minus 6, and square of minus 6 is 36 again, and then 7 minus 10, that will be 3, and 3 square is 9, all in the under root. So this is 36 plus 36, 72 plus 9, 81. So this is root 81, and root 81 is 9. So we have got the length of CD as 9. So correct option to the question is option number C. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।